Welcome back. You are watching YouTube channel 7 Engineering Easy. In this short video, I am going to solve numerical example related to specific weight and density of glycerine, related to specific weight and density in fluid mechanics. In this question, it is given that the glycerine has a specific gravity of 1.26. We have given the specific gravity of glycerine is 1.26 and we are required to find out the density and specific weight of glycerine. The density of glycerine is unknown. Specific weight of glycerine is unknown. As we know that the specific gravity is the ratio between the density of glycerine divided by density of water. We are required to find out the density of glycerine. Rearrange the equation. We will get density of glycerine is equal to specific gravity of glycerine multiplied by density of water. Specific gravity of glycerine will be equal to, we have given the specific gravity of glycerine that is 1.26 and the density of water is constant that is 1000 kg per cubic meter. We will get the density of glycerine is equal to 1260 kg per cubic meter. Now we are required to find out the specific weight of glycerine. For that we have equation that specific gravity is the ratio between the specific weight of glycerine divided by specific weight of water. Specific weight of glycerine will be equal to the specific gravity of glycerine multiplied by specific weight of water. As the specific weight of water is constant, that is 9.81 kilonewton per cubic meter. By putting the value in this equation, the specific weight of glycerine will be equal to the specific gravity of glycerine is given that is 1.26 multiplied by the specific weight of water is 9.81 kilonewton per cubic meter. The specific gravity of the glycerine will be equal to 12.36 kilonewton per cubic meter. If you need to convert this into Newton per cubic meter, multiply this with 1000, kilo mean 1000, we will get 12,360 Newton per cubic meter. In this numerical example, it is given that the 4 liters of petrol weighs 28 Newton. Calculate the specific weight, specific volume, and specific gravity of petrol. In given data, volume of petrol is given that is equal to 4 liters. In order to convert these liters into cubic meter, we have relation that 1 cubic meter is equal to 1000 liters and 1 liters is equal to 1 divided by 1000 cubic meter. Multiply this 4 with 1 divided by 1000. So 4 multiplied 10 raised to power minus 3 cubic meter is equal to 4 liters. It is also given that the weight of petrol is 28 Newton. We are required to find out the specific weight of petrol, specific gravity of petrol, specific volume of petrol, and mass density of petrol. In order to find out the specific weight of petrol, we have a relation that specific weight is equal to weight divided by volume. We have given the weight of petrol that is 28 Newton and the volume of petrol is 4 multiplied 10 raised to power minus 3 cubic meter. We will get 7000 Newton per cubic meter is the specific weight of petrol. In order to calculate the specific gravity of petrol, we need to first find out the mass density. The mass density is equal to specific weight divided by gravitational acceleration. Specific weight is equal to 7000 Newton per cubic meter and the value of g is 9.81 meter per second square. The mass density will be equal to 713.56 kg per cubic meter. Now we are in a position to find out the specific gravity of petrol. The specific gravity of petrol will be equal to mass density of petrol divided by density of water. The mass density of petrol is 713.56 kg per cubic meter divided by the density of water is constant that is 1000 kg per cubic meter. The specific gravity of petrol will be equal to 0.71356. Next, we need to find out the specific volume of petrol. For that, we have relation that the specific volume of petrol is equal to the gravitational acceleration divided by specific weight of petrol, or it is the inverse of mass density. And we have already calculated the mass density, that is 713.56. The specific volume of petrol will be equal to 1.4 multiplied 10 raised to power minus 3 cubic meter per kg. And in the last, we have already calculated the mass density, that is 713.56 kg per cubic meter. In example 3, it is given that the volume of a liquid is 1.50 cubic meter and its mass is 1200 kg. We are required to find out its density, weight density, specific gravity, and specific volume. First, we need to find out its density. We have the relation that density is equal to mass divided by volume. And we have given the mass of a liquid is 1200 kg. The volume of a liquid is given, that is 1.5 cubic meter. In order to calculate this, we will get 800 kg per cubic meter is the density of the liquid. In second step, we need to find out its weight density. We have the relation that weight density is equal to weight of a liquid divided by volume of a liquid. As we know that W is equal to mass times gravitational acceleration and divided by volume. Mass is given, that is 1200 kg. The value of G is 9.81 meter per second square. Divided by the volume of a liquid is given, that is 1.5 cubic meter. In order to solve this, we will get 7848 Newton per cubic meter is the weight density of liquid. In third step, we need to find out the specific gravity. We know that the specific gravity is equal to density of liquid divided by density of water. The density of liquid is 7848 Newton per cubic meter and the density of water is 9810 Newton per cubic meter. In order to solve this, we will get the specific gravity of liquid, that is 0.8. In the last, we need to find out the specific volume. We know that the specific volume is equal to 1 over density of liquid. The density of liquid is 800 kg per cubic meter. We will get the specific volume of liquid, that is 0.00125 cubic meter per kg. That was all about the numericals related to the first chapter from the fluid mechanics book.